go. Got that one intact. Awesome. Alright. So I got the grid unhooked, got the screen grid unhooked, and I got the filament unhooked. And what I'm going to do, I'm just going to cut that ground and I'll replace it. Alright, so the next thing is to cut that socket out, or drill that socket out. So I'm going to pause you a minute and I'm going to go get my drill. I'll be right back. Alright, here we go. There's the horizontal output socket right there, so I think. Get that meter out of the way. I'm just going to reach in here with this big old destructive drill. Let me check this shot, make sure guys are lined up. Of course you can't see a thing. Of course it's going to walk all over the place. That's better. I think I got it. I'm okay. Everybody's alright. Don't worry, I'm good. That was exciting. There. Horizontal output socket. Yay. Wasn't broke, it is now. Alright, so what have we got left to do here? I can't see in this viewfinder. Well, there's a hole in the board. Right there. There, cleaned out. Woo! So now I gotta find some hardware. Put that back together with. Funny, it came out of a Dumont, going back in a Dumont. I don't know what to think. The irony of it all. Just what goes around comes around. Find the right screw here. Give me a minute. Give me a minute. Let's see, that's got to go up like that, which means the notch has got to go down. Yeah, it's got to go like that. Yeah. All right. Don't know if I can get away. I think I can get away with screws in here. It had rivets. I think it will. My chair's in the way. I can't never get rid of that chair out of my way. No matter where I go, it's in the way. Should have some nuts around here somewhere. A lot of nuts around this place. A lot of nuts running around everywhere nowadays. This world's getting nuttier by the minute. Yes, it is. I hope you guys are in frame. You look like you are. Yeah, well, it's in the joys of rebuilding, complete overhaul, 70-year-old television set that hopefully the deflection yoke will work and hopefully the picture tube actually works. Hopefully the power supply is in good enough shape. Hopefully the flyback that I bought for it is the right one. Hopefully I put all this stuff back together right. Hopefully I ain't got to change this tube socket mounting screws to something different. Of course, that screw don't want to go all the way in. Make sure what's up with that. Alright, it squeaks a little bit, but by George, it ain't going nowhere. Don't want to over tighten it. I'm just lucky with this old set that has got halfway decent wiring in it. Alright, the socket's in place. So let me take you out of this. A little bit of this here. There is the socket on this side here. So what we'll do is we'll just take the damper tube, plug into it, and that looks good enough. So that was a success. Didn't take that long. And then we get the horizontal driver, oscillator. There. Good as new. All I got to do is rewire it. That looks good in there. Alright, so I'm waiting on shipment from Mouser to come in, which won't be in today. It'll be in tomorrow, so about as far as I can go with that. Alright, on to the next episode, segment, episode, whatever. Alright, another day has passed. Back on the Dumont again. And this is C1, A, and B right here. This was in the set right here. It's facing this way. So it's rather loosely installed, but anyway, it's pulled it out. It's supposed to be, let's see if I can get it on there. This is the C1 and 2 right here, or CA and B. So it's a 40 and 120 microfarad respectively at 200 volts. So I'll pull it out and I find this. It's been replaced. It's a spray TVL 2679. 40 microfarad, 400 volts, and 120 at 400 volts. And actually, it doesn't check really that bad. As far as the capacity checks okay on the checker. So this is supposed to be 400 volts, so let's bring it up. See what it does. Alright, here we go. I mean, that's pretty good. Well, no electrolytic. That one there has got a little bit in it. But it seems to be getting better. Well, it's not the best in the world, is it? That one's showing a little bit more leakage than the other one. I mean, it's getting better. I mean, it's possible it's reforming. I think I'm going to leave it in there and just let it run, and if it needs to be changed later on, then I'll change it later on. But that was the 120 microfarad, so it's a little bit more capacitance, which is going to slow it down a little bit. So I think I'll leave that capacitor in here. I'm just going to put it right back in the circuit, clean it up, and run with it. This is what I had to put in it. I'm just gonna let this one. I'm gonna let this one run and see how long it lasts. Maybe a tactical error might short out on me as it goes, but we'll let it stay for now. We'll let it stay for now. Let's see. This is the field right here, so put it back in like I found it. Maybe a little better. It didn't have this thing in very good. There. I'm going to the case was not grounded perfectly good to this. It was just the had a wire ground going back here to the chassis, but I'm going to solder it in here too and solder this wire onto it at the same time. But I got to clean that. I'm going to turn you off a minute. I'm going to clean that up, put a little bit of flux on it, and change my soldering iron tip, and we'll come back and finish it. All right. I'm going to clean this little place off here real quick. Let's see if I can get y'all closer. Right there where I'm at. Alright, put me a little bit of flux on there. Give it a little injection of flux. Oh, let me get that ground wire put in there. Yeah, this capacitor may work for a while, it may short out, but I'm going to give it a chance. I know it's probably wrong, but I was excited to actually see a good capacitor. There. Let's have a look at my handiwork. There it is. Nice and shiny like a little butt. Like a baby's hiney. Now, get you out of that Batman villain camera tilt, like on the old Batman. We'll just wipe that off a little bit with a little alcohol. Oh, it's all nice and shiny. All purty and clean. Yeah. Alright, so next one we got to do, there's a dark colored wire here on the back. Reach around here. Alright, throw those. Actually, I'm going to have to put my tip Well, I need 2 soldering irons. Have 2 different tips. That's a pain in the butt to have to pull one and change the other. Well, I thought it was ready to roll. Could have brought out Big Bertha, but I didn't feel like it. Alright, here we go. We'll solder the back one. Good fresh solder. 21st century solder. Alright. The other lead of the choke on the filter choke on there. Get that to bend. I didn't measure the filter choke, but I have no reason to believe it's not any good. Got problems, so I'm just going to leave it alone. It ain't bothering me. I'm not going to bother it. All right. There. Love the smell of this old stuff. There. There is the filter capacitor. Looks a little better than when I started. And also, it's tight. It doesn't just rattle around in the chassis now. Double grounded, it's soldered to the ground here, and it also has a black wire here that comes over here to this test point right over here. So that's good. So I guess while we're still waiting on parts, I guess let's focus on what to do with this one here. This is a 4-section capacitor right here. So that's the next. Waiting on this capacitor to come in. I ordered a 4 at 50 volt. This is a 4 at 200, so I had to reorder that. Then I got these caps here to change out, so we got a little bit of work to do on that. I'll try to get that done before UPS shows up. When I get that done, UPS ought to be here, then we can finish repopulating the horizontal output socket and get all that buttoned up, get all this stuff buttoned up, and I think it'll be time to put the fly back in and do some resistance checks and make sure everything checks out according to the resistance charts. And if that checks good, then we'll see if we can apply power to this bad boy, see what happens. Oh, and I keep forgetting to order these damn safety caps right there. This is the 2 AC input line filters right here. I keep forgetting to order those. I think I'm going to clip them out while I got them here. So anyway, I'm going to do that and all this, and I'll bring you back and there's something to see. Real quick, I pulled these mica molds out of the line input right here, the AC line input right here. A couple of 10,000 microfarads, which is 0.01 microfarad. Anyway, the first one checked okay. Anyway, I got this one set up for 25 volts leakage test. Look, shorted. Wow. So, better off without them suckers. I'll order, if I can remember, I'll order some safety caps put in there. Alright, let me get to changing capacitors. Okay, day 7,000 of this Dumont RA164. Restoration. I think I've got everything done on the bottom side of this chassis, I believe. I got the tuner repaired. I've got all the components replaced that I could find. They need to be replaced. The one thing I thought about driving to work this morning, I have not cleaned the on-off switch yet to see if I can make it work better. But everything is done underneath. Chassis cleaned up really good. It ain't spotless and super clean like a new one, but then again, it's 70 years old, right? So it's flyback time. And here is the old flyback. Looks to be OEM. There is the Dumont number. 2000806. I'm sorry, 51 is the number. Doesn't look bad, but it's open between the plate coil and this top coil. I mean the top lead here, the high voltage lead. And it could be fixable, but I just hadn't done it. Anyway, I have a Merit right here, HVO 47 or Thordarson Fly 12 185L. Horizontal output Hoffman, Pacific, Packard Bell. Anyway, this is supposed to be a replacement for that. Love that. Love that old smell. I wish you could smell that. That's one of my favorite smells. Well protected. See what's in here. Doesn't look like it's ever been molested. Little buckling right there, you can see. Actually, the first time I've actually had it out to look at it. I opened it up briefly the other day, but I didn't pull it out and start looking at it. But anyway, let's compare this thing. Here's another bumblebee cap here on the old one right here, 0.047 at 200 volts. So let's look at the mounting base first off. The mount seems to be pretty much the same. Here's two screws holes here, which I think was used. That corresponds to right here. So the flyback basically pushes in right here. You can see the little tabs and screws down here. So that corresponds to that. Okay, so that's a good thing. The same basic design is there. Here's the filament leads for the rectifier, so that's good. This is the lead right here for the to the horizontal output tube, and then this will have to get. I've got a capacitor, and I think it's this one right here. Yeah, 470 nanofarads. So that would be 0.047. All right. So anyway. This is 7, a 5, a 4, T, 3, 1, 2, 6, 8, 9. So all that seems to be the same. So looks like a drop-in replacement. The basic circuitry this thing's designed to work off of. So the horizontal output goes into 9, which is here. Alright, the high voltage comes out the top to the high voltage rectifier. And then 8, which is right here, goes to right here, this 0.047. Alright, the other side of the 0.047 goes to 6. And 6 looks like it might just be a tie point. No, 6, is that 6? 3, 4, 5, no, I'm sorry, it goes to 7. Goes to 7, so this is 8. Goes to 7 through this capacitor right here. It says for all other to replace Hoffman 5156 remove filament. Uh-oh. Memory card. Alright, my camera card got full, so man, I got two 64 gig camera cards full. It's gonna be an episode and a half. Anyway, where were we? It says here to replace the Hoffman 5156 remove filament lead and remount on opposite leg of HVO47 2-turn filament. For all other units, connect the HVO47 as per original circuit. It says here associated parts, deflection yoke MDF72 with coil MWC6. Well, that's interesting. Alright, so I'm going to put the new capacitor in here. This right here denotes outer full. So that will go in like this. And I will put all that together and double check everything, and I think we might apply B+ to it. Alright. Got the flyback prepped. Got the everything that I needed off this one. Put that aside. We got the new one prepped. I went ahead and put the high voltage rectifier socket on here, pre-wired it. I stole a new this was the old high voltage lead right here. It's pretty ratty. Didn't even have a cup on it. The cup disintegrated. Thing is hard as a piece of number 2 alt. Anyway, I just found I had a high voltage doubler that I know I'll never use, so I sacrificed the new high voltage lead and cup to use on this set here, so I ain't got to worry about that anymore. Anyway, all this is prepped, so I just got to push it in here, screw it down, wire it in, and that'll be done. We can move on to more exciting things. So let me get set up to where you might be able to see a little bit of what I'm doing, and we'll start putting this thing in. Alright, first thing we got to do is mount the flyback. I went ahead and put the screws in here and pre-tapped these 2 holes right here. So let's see if we can get this dude in here. I'm going to pull the damper out and pull the horizontal oscillator out. So I can get in there a little better. Goes in a little rail in here. Pushes in. Alright. And so far, so good. So now I got to pick it up. Starting to look good with the flyback in it. That makes it an official television. And see if I can get the 2 screws, or little small hex heads. Little coarse threads, very coarse. And of course, the leads are down in there. So I need a screwdriver with a magnet, which leads me to this guy. This is your friend. Had one just like it, old TV repair days. So it's got a magnet on there, allows me to keeps the screw in place. I'm just going to go in here, put a little bias on it. This centered where I need it. Figure out where my hole is. Trying to be careful with this. There we go, got one started. Alright, very good. Now we put the other one in. Go right in through there. Screwing it down. Alright, that one's home. And that one's home. Thank you there. Alright. Show you what I got. She is home. There's the 2 screws right here. There and there that we just put in. Boy, she's looking good now. Let me flip it back on its bottom. Flip it back on its bottom and try to remember how we unhook this stupid thing. Ah, this thing's heavy. Alright. Let me put my hand here so I can have a target. Battery's getting really low. There's the flyback. But I think what we're going to do next is let's go ahead and mount the rectifier assembly. So that has to go like this. It goes on top of this doorknob cap. And somehow or another, just like that. Got this big old screw right here. It's got to go in there. Let me get my Phillips head. I am excited. It's taken a lot of time and a lot of work to get to this point. Try to be gentle. This doorknob cap, I just can't. I'm sure I've got some somewhere in my stash, and it might be a pain in the butt to find one of them. A little bit of a solder blob right there. That's not good. I don't know how that happened, officer. Fibro. There. Alright. I think we're clean. I think we're safe. I'm going to push it in, twist it, turn it, guide it, and all that stuff at the same time. Gotta be magicians nowadays. Almost there. I gotta get my screws. Screws. Here we are. Alright, need a flathead. Okay, got that one started. And got that one started. Again, got to watch your torque. Remember, this is all mounted on that doorknob capacitor. Alright, got that done. Alright. I had to answer some emails. People bugging me about work. Expect another one here any second. So let's see if I can find a picture of how I took this thing out. That's been a while back, hasn't it? Long time ago. Ah, here we go. I got a picture of it right there. That's how she come out. That's how it's going to go back in, except all new. So let's see. Here is the cap for that. Horizontal output goes here, probably. Yep. Can do something with that. So there is I had to replace this green wire, which I believe goes up here. Let's go ahead and get that one on there. Then go ahead and get that one on there, get it out of the way. It has been, I bet, 40 years since I've replaced a flyback transformer in anything. It's 40 years. That is a long time ago. 35 to 40 years. Oop, got a little bit of solder run off there. Wire not wanting to tag too good. Come on. That green wire I replaced, it just don't want to behave. Light's in the wrong spot. Stupid solder blobs that get in there, you gotta be careful of them. They will get you. If none, I'm hoping none's gonna come back and bite me in the butt. Yeah, I think we got it. Remember, on anything like this that even potentially has high voltage on it, you want to keep all the sharp little pointy things from happening. In other words, keep your solder clean and smooth. Alright, there's a striped one, which I believe it's going to be number 4. That's got to go in here next. That's going on number 4. This one goes over here. May as well do it since I got it on my hands on it. Black and white sets really are not hard to change and fly back in. If memory serves me right, not a whole lot of connections. But the color sets, you know, they have a little bit more going on. Makes them a little more complicated. I know Shango likes them RCAs. He likes them CTC chassis. I don't remember the number, CTC 101s or whatever. I don't know. I'm just calling a number out. See, I like that. I don't know if you can see it good or not. Good, clean connection. Don't want too much solder, but you don't want to be bare either. There we go. Got that. Oh, I love the smell of this stuff, man. Just turns me on. Alright, there's a red one. It's got to go right there to number 3. And then there's a white one that looks like it's below it. So let me put this one on, and that there's got a broken pin on it. I got to take that off without any collateral damage. Matter of fact, I'm just going to clip it off of there. There's some inside the box somewhere. Period. Also, the box is ready. Sorry, I had to dictate a text to somebody. Multitasking. Wish I would have cleaned this up before I started this project here. Let's see. Let me see if I can get that off. Always that one gonna be a little butt. Try to get this all cleaned up. This stuff is pretty brittle. I've been trying not to move much of it. You can come by in the morning, period. I also have your ULM laptop. Sorry, more business. Alright, let's see. I need to go back to pictures. I forgot which one went where. The red wire at 3 and the white wire below it, number 1. So let's just do the white lead, or white wire, when we were trying to get that plug off of. At least this is easy to get to. Alright, let's put a little splash of solder on there. Whoop, back here, soldering iron. What I'm trying to do. What I would really like to do is power this thing up. Power this bad boy up, and we got one here that's not reaching properly. Let me pause you a minute. Let me fix that. I'll bring it back. Well, sorry about that. Last segment there, camera died because of the battery. What you know, at this capacitor I put in right here is I put a 0.47 in. It should have been a 0.047. So I screwed up. And some people might give me a thumbs down on what I'm about to do, but I'm not unsoldering all that mess again. Nope, I am going to thumb it. I'm going to do a loop on each one of them, put it in there. Nothing wrong with it. It's electrically sound. Might not look like a perfect, but on the other hand, I don't see a problem with it. Once I put the cover on this thing, you ain't going to see it. I'm not going to see it, and electrically doesn't hurt a thing. I just don't want to keep messing with this thing. I want to get out of this area right here because I'm superstitious. It's the only one that I could find in the country that anybody's willing to let go of. So that's my story, and I'm sticking to it. Put a little bit of solder on it. Make it all look pretty. Gonna make it rounded. Got to cut the leads off. Try to cut them off flush, neatly. I try to cut it into the solder a little bit, that way it makes a nice little round ball. Okie dokie. Man, I'll tell you what, it's starting to get exciting. Starting to get exciting. Trying to find my rectifier. There's my rectifier. I need to clean it real quick. Clean the junk off of this thing real quick. Excuse me. Had a very healthy meal for lunch today at Sonic. I bought me a corn dog. Got me a corn dog and a small order of cheese tots, excuse me. Just cleaning all the grit film off this thing. Look how dirty it was. I'm just using 409. I usually just put a light amount of water on here, but I'm really wondering how this thing's going to react. It's not going to have any boost until we get the high voltage working. So, you want to look at it? Oh, boy, you got you. There you go, right there. There she is. Flyback has been installed. The correct capacitor of 0.047 at 400 has been installed in place of the 0.47. Don't know how I did that, but that clearly is a 0.047. See that yellow, violet, orange right there? That orange is 3 zeros. So what that does is that makes it, there's 3 zeros. If it was a red, that would have been a 400 and, let me think about that a minute. That would have been a 4700 microfarad. But since it's got 3, that's 3 zeros, means it's 47 and 3 zeros, so that makes it 4700 nanofarads, or 4700 picofarads, which equates to 0.047 microfarads. And that red bar right there, right in the middle, that red well, that's 20% tolerance, by the way, that silver band. But the red mark there, that indicates the voltage. Anything under, what was it, 600 volts or something like that, is just a single bar. So that's a red bar, and red is 2, so that means that's a 200 volt capacitor. Alright, everything is in place. I'm going to put the shield back on it, and that will give me a little stability here. We'll put the shield on it, and I got to put the horizontal output lead on there. I got to do that real quick, but I'll do that and get all that back off camera. Then I'll put the shield on it, and then I see something else I might not have done right. Anyway, once I get all that together, we'll take another look at it. Okay, well, there it is. The chassis is put back together complete as far as the inside chassis. Not that guy. There it is. The horizontal output tube here, what is that, a 6BQ6, not placed in there yet. I don't have the plate cap. I gotta find one. I hate to solder it like they did, but I'll figure something out. Not gonna put it in there right now. Let's see. But everything's done. There's the flyback in its new home. There's the new high voltage lead, goes up to the CRT. There's the yoke plug right there. The yoke plugs in. There's the 5U4 right here, which I have a brand new one right there to go in here, but I'm going to leave that one in there for right now. Not going to have any sweep on it. No high voltage, so it's not going to give me a boost, so I don't know how the vertical is going to work. But I at least am going to power it up to see if my power supply is active, and just make sure everything rudimentarily works, and see if we can get some flame or something. So let me get set up for that, and I'll be right back. Well, she's on her side. She has a power cord plugged into her. I have the oscilloscope right here. A little Kenwood right here, CS4035. Make sure I got this right. Let's see. I'm going to measure the drive, horizontal drive, to the horizontal output tube, which is not in there, by the way. Got the fluke right here, measuring the B+, the output of the rectifier. I have the AC power plugged into my dim bulb tester, and I have my AC power supply turned all the way down, and power switch is on. I don't have the yoke connected. I guess I ought to. Give me a minute. Alright guys, call this a retake. All the components have been changed. I have the yoke plugged in to the plug. I have the high voltage second anode lead far away from everything. I don't have the picture tube plugged in. I don't have the horizontal output plugged in. We want to check things before that, I think. Let's see. We got the AC power plug plugged into the dim bulb tester, and which is connected to my Syncor AC isolated power supply. Let's see what else. I've got the speaker. The speaker uses 4 connections on the plug there, and 2 of them joint take B plus and runs it to the output tube, and then the other 2 is the speakers, which is plugged into my test speaker here. Then right here, the oscilloscope is measuring the horizontal drive to the output tube. See if that's even going to work, what frequency is running. My voltmeter is measuring the output of the 5U4 to the first section of the filter capacitor when it enters the filter choke and the first stage of the pi filter. So let's fire it up, see what happens. We're gonna run it about 60 volts. And we're drawing, can't read that right now, we're drawing probably 1.5 amp scale. We're drawing about 0.3 amps. Showing just a tiny bit of motion right there. You see it? Still nothing major. But we're running it pretty low right now. Just kind of let everything kind of come up gentle. It's been asleep for Lord knows how many years. Don't know how this thing's going to respond. We were up to about a volt B plus. Wow. As the filaments heat up, their filament resistance increases, which in turn gives me more output voltage. So right now we're at 2.4. It's still climbing. I don't expect anything to work because that ain't near enough voltage for circuits to work. But we're just kind of letting everything, like I said, just kind of come up, do its thing. Nothing unusual over here yet. Still blow pretty good. Let's see if we can get a little bit more out of it. So let's see, our output top scale is about 60 volts. Let's bring it up to about 80 volts. Still drawing about 0.253, about 0.35 amps. Now we're up to 10 volts, 12, 14. We're getting a little bit of activity here. You know, when you do a set like this, change as many components as I have without it even being plugged in and turning, you're kind of taking a chance. But in this case here, I took my time with this. Still could have made a million mistakes, but I think I'm big enough and been doing this long enough to figure out where my mistakes were. I did not check resistances, like I said, because that would have took me 3 hours. I'm just going to throw it on there and let's see what happens. Anyway, we're up to 36 volts B plus, and I'm isolated, so let's see what we got here. 35.8, 36. So we basically have there's really nothing pulling it down anywhere. This right here is the 270 volt line right here. I should have 35 volts on there. So I'm just going to measure on the 270 volt line right here. So let's bring it up some more. Bring it up to 100 volts input. Now you see the dim bulb back there, pretty bright. Coming up to 60 volts now. I don't see no fire 911 things yet. Nothing on the oscilloscope. Still ain't drawing a whole heck of a lot of current, but we're up to 71 volts now. Let's see what our primary B plus is. 67 volts. 65. There is a couple, something's using a few volts there. Let's turn this sucker off a while. Blaring us right in the face. Trying to see if I see any tubes lit up yet. Tubes are shiny, that's for sure. I cleaned all the dirt and grime off of them. Yeah, even the rectifier is not quite up there yet. At 60 volts. The light's still on. Let's bring it up to 120. That should give me a little bit more B plus. So she's ingesting about, you see we got something conducting now. You see that drop? Either something absorbing it getting ready to blow up, or we got some tubes waking up. See the B plus drop just a little bit. No flame yet. Probably going to put it on the higher voltage or the higher current bulb. Hang on just a second here. I'll check my emails. About 84 volts B plus still. Still ain't drawing a whole lot of current here. We're drawing less than half an amp. So let's just turn that all the way down. We're going to go into the high side. Let's do this again. We're going to go up to about 60 volts. It's going to give us a little more B plus now. Now we're getting into the big league ball games here now. It came up to about 130. As you can see, we've got some tubes are starting to conduct. So the B plus, the secondary B plus is dropping now, which is a 270 volt line. We're running about 50% of what we normally would. Let's see, I'm trying to see that damper look like it's lit up. Remember that damper is supplied off a different circuit. Nothing on fire yet. I'm looking at the filament string. There's so much light in here, I can't see. The damper's getting power. Oh, look. We have a signal. Let's see. We have drive of some sort. Look at there. Look at there. I don't know what that is, but doing something. I don't know which one of these is the horizontal hole. It's doing something. We're at 102. Well, we only drawn about a half amp. That's a good sign. We're at 60 volts input. Let's bring this sucker up to about 80 volts. Dim bulb back here. I think I got too big a dim bulb. I'm getting better drive now. I really can't believe it. She's awake. I wonder if the vertical's working. That yoke, boy, seen better days. A little fluctuation there. Something's breaking down. Don't hear no audio yet. About 168 volts. We're drawing about 0.5, 0.55, 0.6, about 0.62 amps. Right now we're just at 80 volts, bringing on up to 100. Now our B plus is over the 200 volt mark. We've gotten a lot more dry. Oh, I think that wiggling is my scope. Yeah. I don't know where the horizontal hold is. There it is. It's adjusting the frequency now. Oh yeah, we'll start seeing some tubes lighting up now. See it right there? Wow, I can't believe it actually works. With 214 volts right there. Look at it, we had drive. That is amazing. Don't know what the frequency is. If this scope would reach. See what this scope has to say about it. Just put it on 2. Alright, let's get it out of XY mode. Channel 2, we're going to sync it to channel 2. Alright. Make sure that's in variable, so let's see what the cursors do. Let's see. Use both hands. We'll put that one there, then we'll take this one. Well, shoot, I got to do it this way. Put that one there, put this one over here. Oh, look, 16.30 kilohertz. That's better than I expected. That's pretty close to 15.7. Well, let's go back down here. I'm curious now if the vertical is working. I am amazed. Still don't hear no audio. I don't smell nothing. Audio output tube's warm. I hear a little bit of snap, crackle, and pop. Wonder if we get any static. 216 volts. And we're running about 100. Let's bring on up to rated voltage. Got about 250 right there, and I forgot what the secondary filament voltage was. I mean, what's the secondary file? 260. So we're just a little shy of it. And of course, the output, the rectifier weak, we're at 250 volts. It is living on what it's probably going to live on, other than the don't hear no audio output. Wow, that is amazing. Here's the vertical output. It's warm, doing something. I don't know what. Let's see if I can remember which one the plate is on this guy. I believe that wire right there is the plate. Yeah, she's got full voltage on her. More or less. We have sweep. We actually have vertical sweep. That is amazing. We have vertical sweep. There's vertical hold, I would assume. Look, it's out of sync, and locked right there. Look at that. That is amazing. That is pure amazing. Don't know if the yoke's working or not, but should we try the horizontal output? That is amazing. That's a little better right there. That is amazing. I'm real tempted to put a horizontal output tube in here. Shall we? Oh boy. I am just impressed. Impressive. I don't know why I ain't getting no audio out, but we'll worry about that later. Of course. I'm trying to get this tube out, guys. I'm sorry. I grabbed the wrong side of the box. Let's see, yoke's cool. Alright, do a trick old Shango taught me. Never seen this before, but I do this stuff in my broadcasting. I see how much current the output, the PA tube is drawing. Same thing right here. Get it all away from everything. So, here we go. This thing could blow up for all I know. Horizontal output tube is lighting. We are drawing some current. We're at 50 milliamps. Showing about 50 mils right now. That ain't a whole lot. B plus is down to 189. Dim bulb is drawing a lot more power. Shall we bypass it? Let's go up to about 70 volts. About 89 volts. Let's see here. Bring it up to about 100. And our B plus is up there where it belongs. Now we're drawing a little bit more. So about 50 mils, 55 maybe. Wonder if we got any B plus. This can be hard to do with one hand. Let's get the trusty old high voltage probe. Stupid thing ain't been uncurled in 600 years. Put this over here in a safe spot. See if I can do this without getting killed. Look at there. We got 11 kilovolts. That is amazing. I would not have expected that. We have 11 kilovolts of high voltage at about 60 milliamps of plate current. That is amazing. That is amazing. I almost touched that. That's glare from the lights. That is amazing. I mean, 55 milliamps. That's amazing. I'm pretty sure that's normal for this set. Amazing. Wow. I am impressed. Tempted to throw this whole damn thing back in the cabinet and see if it actually works. That means the yoke and the flyback like each other. One thing I never realized in my pre-early days is that the yoke and the flyback work together to form a tuned circuit. Never realized it before. Nobody ever taught me that. And Shango, I saw him using one of these one day, and he was talking about flybacks, and he was making another type flyback working on RCA, and that's where I learned. And being I work, you know, broadcast transmitters and all this kind of stuff, like I just never thought of that. So I take some demerits from my boss, my first boss, not teaching me some of this stuff. Also, my vocational school teacher never taught me this stuff. Never taught me the relationship between the flyback and the yoke and how important that they are. That they were tuned circuits. And they may have told me that, I may have forgot, but that is amazing. Amazing. Let's bring it on up. The old rectifier seems to be alright. Let's see what we got here. So we've got about 50, 55, let's see, that'd be about 60, about 62 mils. I gotta look up the specs on that too to see if that's normal or not. Don't seem abnormal to me, but I'm getting a dose of x-rays right now. Let's see what the high voltage came up to. High voltage is about 15 kilovolts. I am impressed. Wow. I'm going to pull the horizontal tube, output tube again, and I want to look at that audio, find out where my audio is. Wow, guys. Wow. I am excited. I have vertical drive. I have horizontal drive. I have vertical deflection. I don't know if it's what it's doing on the yoke side, but I have horizontal drive. I have horizontal high voltage, about 15 kilovolts, plenty of high voltage. Seems to be relatively on frequency. The vertical seems to be locking or stable. This Dumont is what I like about this stuff, bringing this old stuff to life. Now how many more problems this thing has, I have no idea. But that area right here, that was a pain in the butt. Everything was so... Whoop. That's amazing. Let me take a station break. Alright. So I went ahead and pulled the horizontal output tube so I can figure out what's up with the sound. I'm ecstatic. This thing actually works. That's amazing. So, looking at the horizontal audio output right here, I'm at the volume control, which is right here. I don't have any signal at all here, so I'm going to take and apply a signal from a tone generator. Let's see, what kind of tone generator can I use nowadays? I got one way over there, I don't want to get to it, so I guess I'll just use this one here. We'll put about 600 ohms. We'll turn it down. We'll get this lead right here. I think it'll reach. Do unbalanced. Turn the amplitude to about 0. See if we can get some tone out of this bad boy. A little bit of audio, not a whole lot. I don't know the shape of the audio output. I really don't know if this thing has an audio output. Yeah, right there. So 110 volts. So anyway, the volume control is feeding the AF amp 686, which is this guy. Alright, I'm checking the audio output stage here, and I've got a tone injected to the input of the volume control, which is right here. So what I want to do is I want to look at this AF amp right here. The 686 on pin 1 is the grid and 7 is the plate. So let's look at that. So that tube is right here. Let me get that little light. So here is pin 1. See how low the signal is, but it's there. There's your signal right there. And then doing this in one hand. So 1, 2, 3, 4, 5, 6, pin 7. There's pin 7. So that we have plenty of gain through the preamp stage. So need to check the grid of the output tube. So we'll go from pin 7. We need to find the grid of the output tube, pin 5, and work our way back. There's a 470 in there somewhere. There's a 470 right there. I have a capacitor right here going to ground. Looks like I may have wired something up wrong. There's a 470, there's a 100K and a 470. I think I wired something up wrong. See it now. The 470 and 100 right there. So between pin 7 of that tube and there, I should have a capacitor. Oh, there it is. It's disc ceramic. There it is. I see it. Okay, I see it. See if we can get in there. Disc ceramic capacitor.